right, let's do an example of sketching the graph of a rational function. This is going to be long, so hang in there. We're going to sketch the graph of f of x equals x plus 2 over x squared minus 9. And when we graph a rational function, we have several things to take into consideration, and I've kind of listed them over here. Let me go through those one at a time, and then we'll go through them in detail. We want to find the domain. We want to cancel any common factors. Then we want to find the vertical asymptotes, horizontal asymptotes, y-intercept, x-intercept, if any, and then we want to plot points enough to fill out the graph. All right, so let's get started. The first thing we want to talk about is the domain. So the domain of a rational function is all the numbers that can be plugged in without causing division by 0. And so we're interested in the zeros of the denominator. Right? So let's go ahead and look at that. So we have x squared minus 9. Where is that 0? You can see that this factors into x plus 3, x minus 3. And so we have x equals negative 3 and x equals 3. These values must be excluded from the domain. So the domain is going to be negative infinity to negative 3, negative 3 to 3, and then 3 to infinity. All right, that's the domain. And now we want to cancel any common factors. We can see we could write this as x plus 2 over, and we factored that down here, x plus 3, x minus 3. You can see there are no common factors. So this is in reduced form, and that tells us immediately the vertical asymptotes. So we know that there are vertical asymptotes at x equals 3 and x equals negative 3. And we can go ahead and plot those on our graph. So here we have positive x, 1, 2, 3. So we have a vertical line here. I'll just put that in as a dotted line. And negative 3. So 1, 2, 3. All right. The next thing to look at is horizontal asymptotes. That depends on the degree of the numerator and denominator. So we have the numerator, x plus 2. That's a linear polynomial. That is of degree 1. The denominator is x squared minus 9, which is a quadratic, degree 2. So the degree of the numerator is less than the degree of the denominator, which means the x-axis, the line y equals 0, is a horizontal asymptote. And we can go ahead and sketch that on there as well. Okay, other things we can look at are the y-intercept and x-intercepts. The y-intercept is where x equals 0. So we'll plug in 0 for x, see what we get back for y. We have 2 then in the numerator, and then negative 9 in the denominator. So negative 2/9. So that's negative 2/9. So probably, so like almost a quarter. So I'll put the dot right about here. So there's the y-intercept. Any x-intercepts, that would be where the numerator equals 0. You can see that at negative 2. So negative 2. So there's another point on the graph. All right, the next thing to do will be to plot some extra points to figure out what the rest of the graph looks like. We're going to have stuff over here perhaps, some things in here, over here to get the shape. The only thing we know right now are 2 points. So what we're going to do next is we're going to build a table of some values, and we'll see what that looks like here So taking some time here to fill out a table of values for this rational function. Here are some x values, and I've been careful to include some values close to the asymptote because the behavior of the function changes very rapidly as we approach the asymptote. So the more points you can fit in there, the better. Let's start here on the left and add some points going to the right. -5, so 1, 2, 3, 4, 5. The output is negative 0.1825. So that's about a fifth. So put that right there. -4, we have a negative 0.28. It's about a quarter. It's a little bit less. And then at -3.5, so halfway, we have -half, about. 3.1 is -1.8, so about -2. In any case, we can kind of see what's going on here. The graph has to approach its horizontal asymptote, and it's going to fall as it approaches here. All right, so we have this shape right now for this graph. All right, it's going to keep going that way, going down. All right, let's move over the asymptote. So we're through here. -3 is undefined. We have the vertical asymptote here. Circle that. And then below that, at -2.9, we have 1.5. So 1.5. -2.5 is about 2/10, so like this. So you can see the graph's going to come down, hit the intercept, pass through, and then at 1 we have -3.7, so about a third. And then at 2 we have -0.8, so almost. And so we're going to fall off 1.6. And then at 1/10 we are at -8 on 1, 2, 3, 4, 5, 6, 7, 8. All right, so let's try to draw this in. And this is down through the point there. Okay, and after the vertical asymptote at 3.1, we have 8. So 1, 2, 3, 4, 5, 6, 7, 8. 8.3. 3.5, we have 1.7. So 1.7. At 4, we have 0.8. So almost 1. 5, we have 0.4. And so we can see this comes down. And then this is going to go out, approaching the asymptote. All right, so there's a rough sketch of the graph of x plus 2 over x squared minus 9.